Good morning, everybody. Thank you for joining us for this today's Library Resources Lab session. We have Daryl French, a trainer specialist from SciFinder, to show us about how to best use it. Daryl, take it away. Thank you.
Excellent. Thank you so much, Daniela. So as mentioned, my name is Daryl. I'm one of the trainers here at CAS. So CAS provides the SciFinder-n platform. And this is a research tool. It's a literature research tool to allow you to gain access to certainly chemical information, but also biological, biochemical information, engineering, as well as physics, kind of a broad science. We have been expanding our coverage. From a background standpoint, I started at CAS as a just out of graduate school as an analyst. So the things that go into the tool that we're going to see today are all done by hand. So I was one of these people. So what my job was is to read a paper, take it in, pull out the compounds of interest, assign roles. We do this for reaction information too. So we would pick up the products and the reactants and the reagents and everything that goes in. And also to pull out concept headings, as well as some other details that we might talk about during the presentation, and put that into the database so that you may search it. Now we do this all by hand. Everything that I just mentioned is done by a human being, by an expert scientist. And our expert scientists have their own areas of science that they work within. I worked in electronic phenomena, and also from a structuring standpoint, I had quite a bit of experience with polymeric materials. But we have people that do biological molecules. We have active pharmaceutical ingredient experts, people that just work with APIs from pharmaceuticals, sequences, so biosequences, both nucleic and peptidic based. And once again, all of this done by hand, and it's done in multiple languages. So I'll point out some resources for how do you get translations and things like that. After that, I became a patent searcher. So I started working at the United States Patent and Trademark Office as a prior art searcher. So intellectual property around chemicals has been and continues to be a very big industry. You have compounds out there that they have such use and efficacy that they need to be protected from an intellectual standpoint. So I worked with examiners using tools like we're going to talk about today to assist in intellectual property pursuits, and mostly establishing whether a molecule had prior art. So you may hear that sometimes when patent people speak. Prior art means, is there something in the literature that indicates that this molecule is new, or its novelty has already been established in a previous publication? So that would be prior art. And then I've been training at CAS for about 2 years. So I'm happy to be here, and I really do appreciate it. We're going to have about 45, maybe 50 minutes, but I want to make sure that there is time at the end for questions. So as we go through, we are being recorded. Please keep that in mind. If you would prefer to ask a question live when we stop the recording, that's fine. But during the presentation, certainly chat your questions out and we can certainly answer those. Where I'm starting us out, and I'm going to chat this webpage to everyone so that you'll have access to it. Generally speaking, my group travels. And so we would prefer, and I certainly would prefer, to do this presentation that we're doing right now live so that we can have an interaction and maybe have time afterwards. But because of the pandemic and the current situations resulting around that, we had more time on our hands. So our group, the trainers at CAS, put together a series of webinars, and these are conducted monthly. And so we have things coming up like material science. This will be actually today. So if you wanted to register and try to capture the try to catch the afternoon session, you may certainly do that. You don't have to have any credentials or anything. It's open to the public. We have many different presentations all the way out through the end of the year but we also record these webinars. So if there's something that I maybe just kind of allude to, or we don't have a lot of time to talk about, or something that later on you would like to know more information on, please feel free to use these as a resource. They're approximately 30 minutes long. Like we will talk about the retrosynthesis tool, but we're going to speak somewhat quickly about some things just because there's a lot to cover in the SciFinder-n platform. But if there is something that you're interested in, there is probably at this point a webinar that's been recorded that you would have access to. So once again, I chatted out this web address. Please look at these because they can be really invaluable. They're put on by my colleagues and me, so you might hear me in some of these presentations. So I often like to start with getting you to the URL. So I'll go ahead and chat this out too. It's SciFinder-n.cas.org. If you don't have credentials, let us know. We'll work with your library to make sure that happens. So at the end of this, you can send me an email. Make sure that everyone has my email. In fact, I'll just send that out right now. dfrench@cas.org. There we go. Please feel free to reach out to me. You have access to people like us. My job is to make sure that you're comfortable with the tool. And so if there are any questions that come up after the presentation today, let me know. Be happy to engage anything. I want to point out a few things that are available within the tool, but we're not going to have time to talk about unless you have very specific questions. One of those is the biosequence addition. So currently we have a biosequence search capability that has been ingrained into the SciFinder-n platform. This is about 9 months old at this point. We came out with this late January. And this is a way to do a nucleotide or a peptide-based search. We have the 3 major ways that professional sequence searchers do this kind of work. We have the BLAST. If you're familiar with NCBI, the NIH's tool that they have free of charge, BLAST will be familiar to you. They have that capability. I will point out that soon CAS will have adopted much of that content. We are working on getting public repositories into our biosequence coverage. But what we are currently using is what CAS indexes. So as I mentioned before, all of the indexing, all of the analysis at CAS is done by hand. It's done by human scientists. And so we do that for biosequences too. So currently you can do a search, a BLAST search on our sequences. And this is both nucleotide and peptide. CDRs are for like antibody searches. So these are conserved domain regions. That's what CDR stands for. And this is a way of taking a look at 3 little snapshots in a biosequence for that antibody type work. And then motif searching allows you to search with variability. You can actually put in a sequence and use bracketing to select alternate options. So I want to point this out. We don't have a lot of, we actually are not going to have a lot of time for the entire presentation, but I'd just like to point out some of the capabilities so that you can take a look at those videos or ask me questions afterwards. What I'm going to start with is a reference search. It's free text. You don't have to learn special coding or anything. You can just put in text terms, a sentence if you would like to. There is no special way to enter text in. So I'm going to put electroluminescent quantum dots. You'll notice the auto text is appearing, and that's giving us an idea of other terms that appear within the literature that CAS has picked up that might be useful. So the auto text slants very much in the way of science. So this can be really useful, especially when you're exploring a new subject, to get some ideas of other ways that something may be represented. I'll point out that if you wanted to do a substance and a text search at the same time, and this sometimes may be a little bit more advanced for an introductory session, But I wanted you to keep in mind that that is something that you may do. If you had a structural core unit, a moiety of some sort, whether it's an elaborate ring system or just a carbonyl group or something like that, and you wanted those words to be associated with the text and the substance together, that's something that you can do. You can actually do those concurrently, which is a very nice capability. There are advanced search capabilities too. You have the ability to tell the system, well, I would like to look at a publication year range. I have a very specific range. I don't want to see anything from old. I want to see the last couple of years or something. You can start that way. You can also take a look at publications from a specific organization. So if there is a university that is doing a lot of work in your specific realm of science, you could take a look and say, I want to see molecular containers from the University of Seoul. Ask me how I came up with that. It's my graduate work. And specific authors, because oftentimes you're going to be wanting to take a look at people that are doing work similar to you. So not just organizations, but specific persons as well. So these advanced capabilities are just right here. We're not going to use them. I just, once again, want to point out so you know where things are so that you can refresh yourself when it comes to that time. We'll execute this free text search. Something that you may notice is that we have a relevance ranker. That is a new feature, and that's my sorting is the wrong way. I'm looking at newest, but I would like to look at relevant first. If you're running your first SciFinder-n search, relevance will be the way that it starts. It remembers what you have selected and you're sorting from the past. So I had been looking at newest publications from another search just recently. And the relevance ranker is trying to work the same way that your search engine of choice works. It's trying to put the publications that match your search up at the top. Our criteria for a relevant publication takes into account many different facets. If the text appears in the title, it gives higher weight to title text being highlighted, and we'll see that in blue here. It also takes into account how many times and what proximity between terminology is. It also searches concepts, keywords, and substance information. So if you put a specific, substance name, we'll do this with the search within in just one moment. It actually searches that, and that plays into the relevance. It also takes into account citations. So a highly cited publication gives it a bump in the relevance. All of this trying to get you to the best publication at the top. This is a very nice way for you to get acquainted with a new research project. We were going to put those best publications at the top. You'll have that option. But as I kind of alluded to, you can change the way that the sorting goes. You can change this to newest or oldest or the number of times cited. So highly cited will appear at the top. Anytime that you see a search, you can save it. You'll say, well, that's 290,000. Isn't that too many to save? No. You can save anything all the way into the millions if you would like to. You can reduce it, of course, but I like to point this out because a lot of our users want to see a lot of information, and then they would like to see updates. So what you can do is you can save a search and then be alerted to new publications that match your criteria. You can do this for a reference search like we're doing now, a substance search, which we'll do in just a moment, and also reaction searching. You can also be alerted to new citations within a publication. I'll show you that in just one moment. So I just will point that out. And then we have sharing tools, but I want to talk a moment about what CAS does and how you can use this to your advantage. So what we see here is we have a publication that we have picked up the record for. There is full text options. The full text options are based on what you have subscriptions to within your university. I always like to make sure to make it clear that SciFinder-n is trying to take you to, good publications, but you're going to have to go into the full text yourselves. So this is what we call an enhanced abstracted database. So we have the abstracts, but CAS enhances that with substance, reaction information, other processing, and then also things like doing just the kind of the total indexing and making connections in the background. So we have the full text options, but what I want to do is go to the CAS record for a publication, and that is accomplished by just clicking on the hot linked title. I can do that in a new tab. You can have as many tabs open as you would like at one point in time. The reason I like to mention that is that if you ever used SciFinder on the web, which is the previous iteration of this tool, which was created in the mid-90s, 1990s, you could not open things in a new tab. So these are things that I always like to point out, because you may run into people and say, hey, I never knew that you could open things in a new tab in SciFinder. Well, SciFinder-n, because it's a newer platform, allows certain things that the older platform did not. But so we'll take a look and see exactly what does CAS do. So this publication, and we have a document identifier, that's how you would gain access to this publication. We also have things like accession numbers, CAS accession numbers, and PubMed IDs. So PubMed in the daily med or Medline database is maintained and contained within SciFinder-n. I always like to point that out because there are a lot of users that do not like the interface of PubMed. So they will use SciFinder if they have access to it. So you have access to that information. If we have two records, so if CAS did the indexing or the analysis of a publication and Medline did the indexing or analysis of a publication, we merge those together. And I'll show you what that means in just one moment. But these are searchable entities. So if you have the document identifier, if you have any of the accession numbers or the PubMed ID, you can just put those into a reference search and find a publication. You can also just paste in a title. And we just made this a feature available just recently, is that it will recognize a title and say, hey, it looks like you're searching on the entire title of a publication. Is this the publication that you're looking for? We'll actually see a little blue box here based on, hey, it looks like you have a title here. Is that it? Or would you like to rerun it as a query itself? Well, once again, we were looking for this publication. So if you have a specific publication and you'd like to take a deeper look at what CAS does with respect to it, there are many different ways to do that. For some reason, my system's running a little bit slowly. Hopefully it'll pick up very quickly. There we go. All right. So CAS is going to make sure that you have access to other key pieces of information: title, authors, the organizations, the abstract. And once again, our CAS analysts go through all of this information and correct things like spelling errors, which happen in titles on occasion, actually much more frequent occasion than you would like to think. We'll include things like the graphic image that they include with the abstract. Keywords are considered like the supplementary terms that you may see in some publications, many publications. The CAS concepts are what our analyst is adding to this content. This is beyond what you could get in a normal search engine. This is why SciFinder-n is really important, because our CAS analyst is trying to communicate to you what is the important features and what was studied within this publication. So in this publication, they did a blood analysis. Now, they may not mention that in the text or title or abstract that they had submitted through, the keywords and things. But our analyst said, okay, we go through this entire paper. There's data. They have a specific table of blood analysis information, and they make sure that you know that this paper contains that kind of a study. Any of these other kinds of studies that you see here, where they're taking a look at electric potential or a specific model, like if you're looking for a very specific mouse model, which happens a lot in clinic or preclinical trial, preclinical work, we pick up that information. All of these concepts are controlled terminology, and our analysts, because they can specialize and have very specific expertise, they can use that information to convey to you what's in the important information within this paper. The mesh subheadings. So as I mentioned before, we condense the Medline record and the CA plus record to one. So our CAS record and their record into one, so that if you know mesh subheadings, the medical subheadings, which is kind of redundant, that's the way everyone says it. If you know your mesh subheadings, you can use those as well. And these will be searched once again when you do a concept search or a text search in general. We'll see that we pick up substances. So this is a polymeric material. Anytime that you see a picture for a substance, you can click on it to get a little bit more information. And their flyout window will come. And you could say, okay, I need to find the 2 suppliers for this polymeric material. How do I know this is a polymer? One way that I know that this is a polymer is from the name, but also there's this funny little square around everything that indicates to you visually that this is a polymeric material. If I would like to see the details about this substance, such as any information that CAS has picked up, including other names, we can take a look at that. I'll talk about substance details in just a little bit. So we have information about this compound, but also what they used this compound for in this publication. This is very important because if you are looking for this copolymeric material in an analytical role, this would be very nice information to have. And these are things that you can use to enrich your search. You can actually connect a published substance to a role and find the papers that have that done. As mentioned, anytime that you see something that resembles a structure, you can click on that, including gold here, to get that flyout window for a little bit more information. My network's running just a little bit slowly, which I would prefer it not to do. But eventually that'll pop out. There we go. I'll talk about the retrosynthetic tool at the end, but the retrosynthesis tool is designed the retrosynthesis tool is designed to help you to make a material from readily available starting materials. Okay, there is a question in the chat. Before we get to the question in the chat, I do want to point out a reference and its citations. That's right up here. We have citations, any of the 41 that cite this publication. There's also a map. This can be really nice if you find that really good review or that really good paper, and you'd like to take a look at what was in the past and what's in the future. While this loads, I will address the questions. So Evan asks, what are the advantages of using SciFinder-n for biosequence searches instead of NCBI platform? Coverage. Coverage is the answer to that question. We currently cover many more patent authorities from a biosequence standpoint. And also, our sequences all come from the literature. What do I mean by that? If you need a published, there are reasons that you want published sequences and not something that comes from a natural source that just happens to be from something like GenBank. Our sequences all come from there. And also, and I guess the third instance is that I know that all of our sequence work is done by human hand. So it's done by expert scientists, and it goes through an editing process. I do not believe the NCBI tool does that. So those are 3 advantages, and you have access to this tool. So you can save a search within SciFinder-n, you can refer to it through your history and things of that nature too. So you have some options after you're done doing the search to revisit work as well. But thank you, Evan, for that question. I really do appreciate them. So the citation map is very nice because you can see what this paper cited. It's cited, about 50 publications, and then you can see the papers that cite that paper. And this can be a really nice way to say, okay, I know that this paper is important. Maybe these papers will be important too because they're carrying on that seminal work and making a citation to that. Moving down just a little bit, you can filter your citations. Once again, you can use those concepts and say, well, I want to see everything that's been done with a human study, or I'm really interested in biosensing, or do a view all and take a look at all of those different types of concepts that have been pulled out. We also can take a look specifically at the backward citations. They're heat mapped, so you can see that this one is highly a referenced publication. I could actually click on that and get a little bit more information and say, oh, wow, that's a really good paper. That's why so many folks are citing it. But it is a review, could be a good place to start with some literature research. The color and heat mapping is based on the number of citations. So you'll notice that the color gets cooler and cooler as the number of citing documents goes down. Citing publications, this is a pretty new publication. So You're not seeing a whole lot out there that's got a lot of citations, but you can see that there are some really important pieces of work that are being cited a lot in 2020 in particular, in the future from this initial publication. So the citation map is right here, just like that. Okay, so now that we have a little bit of an understanding of what CAS does and how they take this information out of a publication and make it something you can search, let's use it to our advantage. We have 290,000 publications, which is too many. I want to talk about filters. There are ways to narrow this down based on what your requirements are. I'm going to include patents, just to show you really quickly a few options that you have with respect to patents. But I'm just going to apply a few filters. That jumped around a little bit on me, which is not a big deal. And I'm going to exclude. Anything that you can include with respect to a filter, you can exclude. What do I mean by that? Well, I can click on any of these and say, I would like to exclude journals or exclude a language-based publication or a date range. If I wanted to say, well, I don't want to see anything, I want to exclude, everything but these few years, you can apply that. You can even use the text search within capability to exclude a term. And so I'm going to pick up a term called, I'm just going to exclude the word luminous, just as an example. Up at the top, you'll be reminded of what the changes to the search you have made are. You can see these at the top where we have the filters, a drop down. We can say, okay, we're including patents and biographies, and we're excluding a publication year. And for some reason, I excluded the word luminous. You can always X out any of these terms and say, whoops, I made a mistake. I did not mean to exclude the word luminous because I am looking at an electroluminescent device. But I could also clear every single filter and get more or less back to where I began. So as I mentioned before, I wanted to talk really quickly about patents because there are full text options beyond just this full text drop-down menu. You have access through the SciFinder-n platform to the Patent Pack tool. If you're interested in patents, let me know. I'd be happy to engage a conversation with you. I just like to show that things are here, especially during kind of an introductory session. But what's more likely is you're probably going to be looking at literature in particular. If you're, one of the issues that I have with patents, even as a patent professional myself, is that they tend to have limited amounts of information. They obscure information intentionally. So the kind of spirit of sharing is best shown in journals, I tend to find. And we could certainly look at reviews too. But I want to just filter this down a little bit so we can see a little bit about how to get a set of answers into something a little bit more manageable. Language. So we at CAS do the analysis or indexing of thousands of journals and 64 of the world's patent authorities. And we have those expert scientists, as I mentioned before, and some of those expert scientists have language skills as well. And so this allows you to do a search around the globe. So you'll be able to say, okay, even though I don't speak one of these languages here, everything will be made available to me in English. And this can be very nice if you're trying to look for something that may be coming from a journal source or just a regional area where they're doing more research than they are somewhere else. And so you'll have access to that through the title and abstract, of course, will be translated, keywords, but those concepts. So our CAS analyst adds that concept information for things that aren't in English. Also reaction and substance information. Once again, all done by hand. We saw publication year, so you can limit your search down there. Available at my institution is based on, that's the webinar for today. Available at my institution is based on the subscriptions that your university has. So we set these up. So that's what you're seeing here. The filters that we see here, though, are nice because now you'll be able to take a look at author-specific searching So if there was a specific author that happens to work a lot in this realm, you could say, all right, Professor Dimberg, we can make a selection, we can do a search. And when I change from tab to tab, it remembers my selections, which is nice because I can make sure that I'm not missing an instance where they represented their name in a potentially different way. This happens a lot in patents, but also journals, that journals sometimes include initials, sometimes they don't. Sometimes they include the full middle name, the full first name. We are working on getting ORCID IDs in, if you're familiar with that initiative. But I always like to point out, especially to a new or novice searcher, you have to be careful with certain tools. There are deficiencies of the ORCID ID program. One of them is that if the author doesn't request an ORCID ID, they might not get one. And so there are authors that have retired or just for whatever reason are not participating. So continue to use the search function on author names, even after we put in the ORCID IDs, which should happen by the end of the year. But the nice thing is that we could say, okay, we have the principal investigator. What about a postdoc or collaborator? So I'll use my last name. It's common enough to appear. And we could find a potential person that also is a real impactful researcher in this area of science and add those in if we would like to. Once again, building a search based on names. And so you could watch someone's lab that you happen to know is really useful for your research. Organization, we saw that before. We can do a view all, and we can see all of the organizations that are doing the most work here, and even do a search here and search for an organization. Publication name. This could be a way that if you know that there is a specific publication that you really like to keep an eye on, you can certainly do that. Those concepts are also something that you can engage through the filtering. And you can say, all right, quantum dot devices, let's do a view all and take a look at electroluminescent. Copy and search. Something I'm going to point you to are wildcard symbols. There are two. There is a question mark. So if I execute the search without putting a wildcard symbol, it doesn't work. And that's because I haven't filled the word in completely. But if I use something like an asterisk allows 0 to infinite possible letters that follow what you've entered. So we will find electroluminescence, also electroluminescent, all of those different ways. This can be a nice way to expand your search and make sure that you're not missing information. The other wildcard symbol is the question mark. The question mark is 0 to 1. So it's a little bit more restrictive than the asterisk. I just like to show these because it's very nice to have that freedom to expand your search a little bit and to put in different words and say, okay, luminescent, luminescence, and go ahead and select those that are interesting to your work. The concepts are, once again, a very nice way for our CAS analyst to communicate to you what was studied in that paper. This is controlled terminology too. So the terminology is approved by a board at CAS. And when they approve those, then they become part of the indexing procedures. We add things when new things come available. In the 90s in particular was a big one that was nanoscale technology. We added that one specifically because the science was kind of demanding it. But another thing that we talked about before is the search within. So as I mentioned initially, and I'll move this chat over here. As I mentioned initially, we can add in text terms to this search. We don't have to use a filter. We have free text searching capabilities. And so you could search on something like germanium or GE, right? Because you can put Boolean operators in too. I'll show you some help topics that might help you get a little bit more acquainted with what your capabilities are from a Boolean search capability. But you can actually use quotation marks. So you can even say, or quotation marks, germanium oxide. And that would force those terms to appear using the quotation marks. It has to be germanium space dash whatever oxide as a bound phrase in that order with a character in between, whatever that when I say character, I mean punctuation, because a text, some sort of a text would not actually work. It has to be separated. And that's because we at CAS, from our database standpoint, handle all punctuation as a space. So dashes are a space, dots or periods are a space, things of that nature. So, but this would force it to be germanium oxide. But the nice thing is that now you have different ways that this could be put in. And when we search, and we go into one of the records for these publications, we'll see, okay, there's the germanium. We can open that publication up. And we'll see that hit highlighting now reflects those new additions that we made into the search that we initially started with. Under substances, we'll see, okay, there's the germanium. Excellent. So you can really build in a search and add layers down to get something more to what you require. And we can do that again too. So if you were looking for nanotechnology, as I mentioned before, you could just say nano and then use the asterisk. The asterisk is going to give you that freedom to say it could be a nanosphere, a nanorod, a nanostructure. There are many different nano sheets. There are all kinds of different ways that nano has made it into the literature. And keep narrowing the search down and add more terms that would be useful to your search. So now it might be a good time to save a search because you've added all of that information in. We could say, all right, today, which is 10/20, it's the 20th of October. Alerts is going to send you an email when there are new criteria that match this search with the filters. So based on this, we want to see journals, we want to see germanium and nano, electroluminescent quantum dots. As available is approximately every other day, and then weekly or monthly. And this is based on the email that you use to set up the account. So likely your case email. Tagging allows you to put all of your searches underneath a subheading that's important to you. So if there's a specific class that you're doing your searching for or a research project, you could put all of your searches under that tag and say, well, this is for my omniphobic project that I've been working on, and I'll save that. If you have a search that you would like to email to a colleague, that's what this envelope is for. You'll have two options. I typically use my default mail app, and that's because I have my contacts list. So I can put in to any one person or a group of people, like my entire research group if I want to. This link, as long as that person that clicks on this link has a SciFinder-n account, it will take them to, within their account, this page exactly as you see it. So now they could save this search to their own account. This is a very nice way of sharing work amongst a group of people and say, hey, let's all take a look at this search. Let's save it because these are going to be important results for, future conquests in the lab. There are export capabilities too. So if you would like to export as a .ris, RIS is handled by all of the major citation tools out there that I know of. So EndNote was a big one when I was in graduate school, but every time that I've gotten this question from somebody that uses something maybe that's more free or open access, also .ris is recognized by all of those tools. And there are other ones too. I use rich text a lot. This will get you a Word file. And then Excel does a really good job of creating a spreadsheet with sortable, searchable, and filterable columns, so you can do some post-processing. All right, cancel out there. Your saved searches are committed here under the star. We saw that before. Your alerts, you can actually see your unviewed alerts. Oftentimes I delete my emails that I get from CAS, which is funny. But you'll see a purple exclamation mark, and that indicates to you that there is a search that has answers that you have not seen quite yet. You can see one at a time. You can also view multiple, and you can manage your results here too. A powerful feature that you may start to use as you become a more advanced and seasoned searcher within SciFinder-n is the ability to combine searches that you have saved. What you could do is say, okay, I've saved some reactions, and I'd like to see where they overlap, or I'd like to see a large set, or maybe make a subtraction because you've already seen some publications. And you can say, okay, I have my Claisen rings, and I'd like to see where it corresponds to this other Claisen set. Typically I like rearrangement reactions because there's a lot going on, a lot of arrows to push. You can view that. So you can do combinations. As long as you can save it, you can do a combination. Well, the nice thing is you can save a set, whether it's very small or very large, it does not matter. And then you can do combinations. Migrate is for anyone that's coming over from SciFinder on the web, the older platform. A constant thing that's running is a history. So every time that you've done a search, you'll get a date and a timestamp. And you can always see the dates and times that you did a search by the purple dots. And if you make a change to the filters, now your purple dots will recognize that you're looking for a substance or a supplier search. And the last time I did one of those was August 18th. So it can be very nice to remind yourself, oh, what was I doing? Because I got some really good results when I did that search on epoxide. Okay, we'll go back to the home page by clicking into the upper left logo and do some substance searching. A thing that I always like to point out is that if you have substance features that you would like to search on, you can do advanced search features using things like, I have a molecular formula. So I took structure elucidation twice because once my PI taught it, so I had to take it when he taught it. So oftentimes in your structure elucidation class, you have a molecular formula. Well, put the molecular formula in, add another search criteria and say, well, not only did they give me a molecular formula, they gave me an NMR. Where is that spectral data? There we are. They gave me some NMR peaks. Put in your proton NMR peaks. They may have also said, well, we're going to give you a melting or a boiling point. And you can execute a search this way. You don't have to do a structure draw if you don't want to, but you certainly could. So those advanced search features can be very nice. But I want to talk about the drawing tool. There are a few ways to get a structure into the drawing tool. You can import a structure. And I always use the example that I have on my desktop, because you may be using a tool that SciFinder-n integration. So if you have ChemDraw 18.2 or above, there is a SciFinder-n button. You can actually structure directly from that tool. But when I was in graduate school, I had to use a free program. So I used Marvin Sketch. And so any of the major drawing tools will allow you to save something, certainly as an MOL file, a mol file, but also CXF is pretty ubiquitous too. So if you have a structure that you've drawn in another tool and you'd like to do a SciFinder-n search, just choose a file from your desktop and say, okay, this is my antiviral, upload that, and you can import a structure in that way. I'll do Control A and delete. You can also put into the box that just was highlighted a moment ago, a smile, an INCHI, or a registry number. And one note about INCHIs is that it has to be the full INCHI. An INCHI key does not work. We execute that search or execute that structured drawing tool, and it imports the structure. It can make things just a little bit easier to find, certainly a lot easier to input in. We have all of the commonly occurring elements here. Whenever you see that there is a triangle in the bottom right, that is an expandable window. So if you're looking for a deuterium or tritium study, they're located here under the proton. Halogens are here, except for the noble or the synthetic halogens. Different bonding arrangements other than single are here. Also, the normalized bond is really nice because it just establishes the scaffold without any hybridization of the bonds. Sometimes you don't care if it's a double, single, or triple bond. All you're looking for is are these molecules connected? That's what this unspecified bond is for. The stereo bonds are here, so out and in, ring systems. The periodic table, which would have everything beyond just the commonly occurring elements. So if you're in particular, if you're an organometallic chemist, you may be looking for, okay, where's the ruthenium? There it is. There's its buddy rhodium, which I worked with. Shortcuts. Shortcuts are nice because it can help you draw things much quicker, especially if you're trying to do a meta phenyl group. If you hover over it, it'll show you that at the 1 and 3 position, there is no proton. That's where the assumed connections are. Variable. Variable can be nice because sometimes you're not, like if you're doing acid chloride chemistry, maybe acid bromide might work or acid iodide. So it's a possibility that you're just looking for a good leaving group. So you can say, well, any halogen, that's a good leaving group, but you can expand that a little bit and create your own variable group and say, well, I don't want any halogen. I have 2 specific ones. I would like chloro or bromo. Remember, it's an or operation. So it can be one or the other, any of these. We could add more of our variables in and say, okay, any metal could work. That's a good leaving group typically, even though it's not that common. We could even use shortcuts and say, okay, a methoxy, ethoxy, alkoxy groups, go through and select those. I can click or type, I typically click because they're there. And now I put this R group here. And if I hover over my R group, it'll remind me what's in there. And I can always make a change. I can put up to 20 different substituents into 20 different R groups. A little bit of an advanced feature is the variable point of attachment. Sometimes you may not be exactly sure where a carbon is being connected to a ring. So you could say, all right, it could be attached here, or it could be attached here. Anything that you can draw, you can do a variable point of attachment, including our R group here. We can say, okay, it could be here on this diazo, or it could be there. And so the variable points of attachment can be nice. I'll undo that and do a structure search, talk a little bit about that, and then we'll finish with some reaction searching, and that'll probably take us to the end. Let's go ahead and press OK. Patent Marcuse structure searching is for the intellectual searcher. So if intellectual property searcher. So if that's something you'd like to learn a little bit more about, let me know. I'm just going to run a regular structure search by doing the magnifying glass button. Remember, the magnifying glass button is committing these to your history. All right, so what we'll see is that we are given 3 options as drawn. Does something match exactly what you drew? And that's what we're seeing here. Substructure allows variability. It allows there to be derivatives. And sometimes what you'll notice is that we get inorganic compounds or organometallic compounds. Analyze structure precision is still here. Some of our users like to see Zwitter ions and or tautomers, and that's what this tool allowed you to do. These are all conventional results. And then there is similarity, which is based on a statistical it's the Tanimoto statistical analysis of the connection matrix that CAS created. That's a very long way of saying that this has been consistent for about 30 years now. This is the way that we've always done it. We have similarity scores all the way down to 60%. It really allows you to expand your search out if you would like to. You'll see in the top right how similar it is to your structure. So you have a 61% similarity. Now, the reason that we're seeing publication or substances that don't really match all that well is because I have sorting set on the number of references descending. You have different ways of sorting your substance results. CAS registry numbers are assigned sequentially. So the largest CAS registry number is the newest. So this can be a date indication. Molecular formula goes by Hill order. Carbons and hydrogens first, everybody else is alphabetical. So keep in mind that H2SO4, sulfuric acid, in Hill order is H2O4S. So keep that in mind if you're doing molecular formula sorting. Weight is pretty self-explanatory. I typically use references because I want to see highly cited compounds, but you could always see the opposite and the number of suppliers. You can save and be alerted on structure search. So these would be new structures that match your original query. Or if you had applied filters, it also takes that into account as well. Email and export capabilities. Once again, anytime you see a substance, you can click on that to get more information, and you can find reaction information, create a retrosynthetic analysis, things of that nature. The filters off to the left here. All of the filters that you see here can be included or excluded, including all the way at the bottom. You can search within based on structural features. So if there's a structural feature that you're seeing, and I'll just pull this registry number, draw. And I'll do some deletions. Where's my delete? There it is. Erase. So if there was a structural feature that you wanted to exclude, you have options as drawn or as a substructure. We'll do substructure. How does one search for quadruple or quintuple bond? Yeah, unspecified would be the answer to that question. And could you show an example of structure search of a metallocene? Yes, yeah, we can do a metallocene too. I might do that when in the question and answer session, but we can certainly do that. But then you can exclude moieties. You could also include them as well. So I like to talk about these capabilities. Okay. With our last few moments, I want to talk about reaction searching, and we'll do this in a pretty quick way. So I'll put in a structure. And something I'll point out to the metallocene question, which is a really good one, is that under our templates here, you will see that we have, where is it? Coordination compounds, which can be very nice because this can be an indication of how you may want to search something. So if you're looking for a cyclopentadienyl coordinated with a metal, this would be how we do that. It actually puts the charges out there. I would also recommend that if you are a metallocycle or metallocene type searcher, strip off all of the charges. So take off the pluses, take off the minuses. Because if you put a plus or minus on and you get it wrong, you could miss results. If you leave it neutral, you will automatically find any charged species. So to keep it neutral when you're first doing your initial searching, and then add the charges after you've gotten a little bit more comfort with what you have searched, just so you don't miss it on the initial pass through. So we'll talk a little bit more about that because I imagine you might have some more questions. So let me undo. So let me press OK. We're going to do reaction search on this material here and go ahead and execute. The retrosynthesis plan is right there. I'll put the retrosynthesis plan at the end. Retrosynthesis would be good if you're a synthetic chemist and you're looking to maybe get a little bit of an advantage on your synthesis homework. Something I want to point out is that this has a stereocenter, and we're going to see that there are only single-step reactions. Under our stereocenter, we're going to see that we only have two options. I always like to show this to anybody that's new to SciFinder-n. If this is happening and you're like, well, I should see other stereo options, and I should see more than just single-step reactions. What you need to do is edit your drawing and use either this tool right here, which allows you to add a reaction role, or use this tool, which is the arrow tool. Whatever the case may be, however you would like to go about it, you need to get the product role underneath your material. Let me show you why. When I add that product role and I redo the search, we're going to notice our as drawn and our substructure goes up quite a bit. And now we have multi-step reactions. On top of that, there are also more stereo options. So stereo that doesn't match, stereo that does match, relative stereo matches, things like that. So I just like to point these things out to anybody that's new to the tool because it's just the way it is. This happens to be a little bit more in alignment with the way the old tool worked. And so we kept it this way just, for anyone that was transferring over. So add that product role. It'll get you the stereo options. It will also get you the multi-step options. There's grouping by publication or by scheme. So are you interested in grouping everything by the document that it comes out of, or just the chemical entities that are participating? Save, export, and email capabilities are here. A few filters I want to talk about, and any filter you can include, you can exclude. I do want to talk about the synthetic methods. So let's go ahead and do that. Click that on, because this will give you access to the synthetic write-up that was available within the publication. I might go with this tetrahedron paper. There are a few other filters. You can include or exclude reagents, catalysts, solvents. You can also search within. So if there's a starting material that you would like to impose upon your reactions, that's there. You can also tell the system where you would like your publications to come from. So specific types of publications like journals or patents, or a specific publication like I'd like to take a look at Angewandte Chemie. So I want to show exactly what you get with synthetic methods. And we'll go ahead and click on the View Reaction Detail. This automatically opens in a new tab. And the synthetic methods is giving you access to what was written up with respect to this reaction. So we have the scheme of the reaction at the top here. And right here, we see all of the participants of the reaction, including solvents. The total procedure, including how they worked it up, if a flash chromatography had happened, or crystallization. We'll also include characterization data. So there would be things like NMRs if they had included them, melting points, and all of that kind of information. The nice thing being is that now you don't have to go to the full text of this publication. You can just say, well, I'm only interested in synthesizing this, so I can print this off as an RD file or whatever the case may be. So we're getting a little bit close. We're getting very close on time. I do want to point out in-app help. There is What's New, which is a specific section of the help menu. What's New is going to show you what has been recently released in the tool. We have about monthly releases, so you'll be able to make sure that you keep understood about what's happening within the tool. If you would like to search help and you are curious about Boolean searchability, you can search help and learn more about, all of the Boolean operators if you would like to, including those quotation marks or the parenthetical statements, wildcards as well. There's also a table of contents. So if you were more interested in the retrosynthesis plan, you could learn a little bit more about that. Also at the bottom of every page, there is Contact Us. We have a help center in Columbus, Ohio, which is where the headquarters of CAS is. And this the customer center is available 8 a.m. to 6 p.m. Monday through Friday at this phone number and also this email. And they can help you with a passcode reset or help with a search strategy if you're trying to learn a little bit better about how to do something within the tool. But always keep in mind that I'm available too. All right, with that, we have about a minute left. I'll put up a retrosynthesis so you can see, kind of the difference between retrosynthetic design and its use of the reaction database. But I want to open the floor to any questions because it'd be nice to do that. Metallocene. Yeah. So the metallocene question, while everybody else is taking themselves off mute, or if you have to go to your next class, I understand that too. One way to do a metallocene is do a substance search. And I'm going to do rhodium norbornadiene because I know that one. I would recommend that if you are doing a metallocene search or any sort of a bicarbocyclic, not even connect them and see what happens. The reason that you don't have to connect them is because it will automatically do the search. Now this rhodium should coordinate to 2 it should coordinate to 2 norbornadienols. I only have 1, but I can always just say, all right, I want rhodium and this, press OK, do a substance search. You don't even have to connect them, especially when you're just trying to establish, what's an eta bond, what's a sigma bond, things like that. We'll see here that it's connected to 2. So this happens a lot. And so you don't even have to connect them. Another option that you have is that you can click on a substance, and let me find one that doesn't have a bunch of other things in it. Anytime that you see one, you're like, hey, yeah, that's exactly what I'm looking for. There's edit structure. edit structure will zip that over to the structure drawing tool, and it may look a little bit differently. And I remember, I told you to be careful about the charges. So if you'd like to change those charges, you can always say, well, let's make that neutral. Press OK, and then execute that search. So you don't even have to make the connections if you don't want to in that exploratory search. But once you get your feet underneath you and you would like to do the connections, go ahead and try that. Excellent. I really do appreciate the questions. Okay, I've gone over. Please feel free if you have some other questions. I'll give you a couple minutes, but I'll also be more respectful of your coordinator's times. Everyone's very busy, but I'm not seeing anyone do that. So, okay, excellent. Well, thank you so much, Zoe. Yeah, and let me hand it back over to Daniela. Thank you all so very much for your attention today. Please feel free to reach out to me if you have any questions, or just anyone at CAS, and also your library staff. We're all professional searchers, and we'd be very happy to help you get started on a project if you need to. But thank you again.